first is a percent of increase. Percent of increase. So we'll talk about percent of increase. Guess what we're talking about after that? Percent of decrease. Okay, so hopefully not too confusing there. All right. No, it's a whole lesson. Well, hold on. I hear a lot of questions, no hands. Look on the top of page 226. That first example, someone's going to read it. Okay, Kaden, you'll read it. Yes, Dalen.
So is the lesson percent of change or percent of change and percent of increase?
It's percent of change, and the first type is percent of increase. And then the second type will be percent of decrease. Okay, Kaden, go ahead and read for us the sand shack.
Sand shack marks up the price of its large iced tea from $1.89 to $2.19. What percent of increase will it?
Okay, the first thing you want to do with these problems is note what is the original amount in this problem. So what was the original amount of that sweet tea? Iced tea. Strange, right? Okay, yes, sir?
It was $1.89.
It was $1.89. But then they changed the price, and we'll call that a new amount. And they changed the price to $2.19. Okay, I'm asking for the percent of increase, but before I find the percent of increase, I need to find the amount. The amount of increase. And I'm going to abbreviate the increase now. Amount of increase. So how much did it go up is what I'm asking for. Like dollar and cent wise, how much did it go up? So how do you figure out how much it goes up or down?
219.
Henry.
Subtract 219 minus 189.
Yeah, so 219 minus 189 gives us, I'm going to put it like this, 30, it's exactly 30 cents there, 30 cents. So you did 219 minus 189 is 30 cents. That's the amount of increase. So it's my answer, if they ask, what's the percent of increase? You say 30 cents.
But 10 minus 8 is 2. If you put the
No.
219 on top, because you put the bigger number.
The 9 and 9, that gets me 0. And then the 1 minus 8 you can't do, so you got to borrow, and it ends up being 30.
But it ends up being 10 minus 8.
Wait, so you're supposed to do 8?
You see that?
219 minus 8.
Okay, sorry, just to make sure, because we don't want to assume that it's right if it could not be right. All right, here's the formula for the percent of increase. You take the amount, and again I'm going to abbreviate, amount of increase, which we just found out, 30 cents, and you put that over the original amount. You put that over the original amount. So what was the amount of increase? 30 cents, which you could put now as 0.3 because you're actually going to work it out. And what was the original amount?
189.
189. Okay, this is where I'm going to ask you guys to find your percent on your own. Do whatever you think you need to do to find out that percent. I'm just giving you that info. I want to see how you handle it. Then I'll tell you what to do. So I won't leave you just by yourself.
But for money, you kept the 0.
Well, yeah, but when you're actually working it out, like when you're dividing these out, you don't have to keep extra zeros. All right. How many of you are using a proportion? Good. So are you doing this over this equals x over 100?
Okay.
Great. You use a proportion. How many of you are just dividing these two numbers together and then you're going to move the decimal twice at the end? Okay, either way. Good, guys. You're thinking through it. I didn't tell you what to do. You did it on your own. How many of you are not doing either one of those things? You're doing something different? How many of you refuse to raise your hand in class? How many of you refuse to raise your hand in class? Okay, good. Awesome. Made you raise your hand. Okay. I did that in class. I've done that before because I want feedback and I'm like, all right, how many of you just will not raise your hand in class? No matter what I do, you won't raise your hand in class, and someone proudly raises their hand. Oh, and they look, oh man, I'm so sorry. Thank you for raising your hand. Yes.
For
divided by.
Oh, no. 0.3 divided by. So this goes in the box, so it goes outside.
Okay,
Yep.
so that would be formula, and then proportion is that.
That. Okay, I'm going to do this on another page. Maybe not. This one. Okay, so I got 0.3 times 100 is 30, and then 1.89 times x is 1.89x. All right, so I'll do 30 divided by 1.89, which requires now I move it. Okay, 189 into 3,000. And I'm going to tell you where to round these because a lot of them, they require rounding. Round it to the nearest whole percent.
Wait, why can't you just do it now?
Well, you can. I said you could do.
30.
But remember what I said, Daylin? You could do either way. I'm doing it one way. You could do it that way. All right, 189 goes into 300 once. That's 189. And then that's 1110. Okay, 189 goes into 1,110
9. No, not 9. 5.
5 times. And I'm going to do that math over here because who knows, maybe that's...
It's 945.
Oh. So 45. I'm just checking just because we don't want to... 44. 90. Okay, 945. 945. That gets me 165 with, and now I got to go one more time. Got to go one more time because I got to round it properly. 189 goes into 1650. Anyone?
I haven't gone there yet.
I didn't get there.
That's okay. Yep. Somehow I could tell. Tyler, what do you think? 189 into 16. Just guess. I mean, I don't know. 189 into 1650, about.
8?
Okay, so I'm going to do the work. I'll do the work. So 72, 64, 71. Oh, nice. And that's it. 8 times. So I'm done. I don't have to keep going. What does that round to, though? 16%. And was it an increase or decrease? Increase. So that price increased 16%. So when it went from 189 to 219, that was a 30-cent increase, which is 16% of an increase. Ma'am.
So, we all, for these specific problems, we will always round to the...
I'll tell you what around. Sometimes they'll say to the nearest whole percent or tenth of a percent. So I'll tell you.
And I'm still, like, even though we've been doing this for a while,
It's okay.
I'm still confused why, when you move that decimal 2 times over, you have to add 2 more zeros. I'm
Oh,
very confused on how that
like
works.
here and here?
Yeah.
Okay, that's 189. Sorry. Actually, does anyone know the answer to that? There is an answer to that, and it should be relatively, I mean, it's mathematically true, and it's, I hope you're like, oh, that makes sense. Okay, why? So I wrote it like that for a reason. What do you think, Jimbo? Yeah, I'll get your question.
So if you move the decimal point, then there's a lot of space in between the number that you're writing and absolute 0. So 0 is a value that doesn't really mean anything. So if you place zeros to show how far it is away from the decimal point, then that will make the number not like you have a 15 over here, then you have a 3 there, and there's no way to know if that's 153 or 1,000 or 1,503.
Okay, so you can just kind of, you can put zeros in as long as you're keeping things balanced. I mean, I kind of get that absolute value, but it's actually simpler than that. It's really cool why it happens.
What you do to the top, you do to the bottom.
Okay, ready guys? Here's a little math problem that you do every time you move that decimal twice or 3 times or 4 times. Here it is, ready? If I multiply this fraction by 100 over 100, what am I actually multiplying it by? 1, right? So that's the identity property. That means I don't change the identity. It's the same thing. You close. What's 30 times 100?
3,000.
And what's 1.89 times 100?
189.
Isn't that the division problem we're doing?
Yep.
So all I did, when I moved the decimal, I'm multiplying by 100 or 1,000 or 10,000, depending on how many times I need to move it. But then it makes it into a problem I can actually do. Because if I can't do 1.89 into 30. It's like I can't compute it. Move the decimal. Does that kind of explain why?
Yes.
I think that's cool because how many of you knew that? Okay, maybe one of you, right? And she told me, guys, are we doing things that are like just random? Like, you know what? Let's move the decimal. Are we doing that really in math? Do this. No, there's always an explanation as to why, but I know sometimes it seems like that's random. No. Okay, yes, ma'am. Go ahead and write that problem when she's giving me the
You
question.
have to move the decimal twice because I got 0.16%. It's like I don't get like
Oh.
why if you do it this way you have to move the decimal and if you do it that way you don't.
Yeah, because you just divided, right? You did I think you did 0.3 divided by 1.89.
And then I moved
Moved
the
it
decimal
twice.
30 divided by 189.
Uh-huh. So then you get the 0.1, oh yeah, 158, 16 rounded. Okay, you got a decimal number of 0.16. That's a decimal number, right? But how do I make that turn into a percent?
Divided by 100.
Times by 100. And so now you do that. Yeah, because I'll just give you a little spoiler alert. Both ways are the same thing. It's just they go in different order. Okay, here's the problem.
Wait, what's the point of the new amount?
Yeah, let me.
Oh, you subtract.
Okay, here we go. I want to know what the percent increase was. Do you guys understand that it went up? Looking at that, it's like it went up, right? Pretty dramatically. So it went up from 245 to 1470. What was the amount of increase? What was just the amount? 1,225? Okay, 12 or 1,225 or 1225. Okay, that's how much it went up. That is not the percent that it went up. It is not the percent it went up, is it?
No, it's the amount.
Okay, it's the amount. How do I find the percent? We take the amount of increase and we put it over the original amount. So what was the amount of increase?
1,225.
All right, and what was the original amount?
245.
Okay, before you work it out, I need your skills in estimation. About what percent would that be? So raise your hand. Give me an estimate here. Don't say anything but the number I give you. Don't try to say, well, I did this and that. Just give me an estimate. That's all I want. Okay, yes, Ruth. 5.
I don't know.
That's okay. Aiden.
Somewhere around 20%.
20%, okay?
I think a little bit more than 20%, maybe 25 to 30%.
25, 30%.
Well, mine's
Go ahead. Same as them. I'm thinking about 500%. Yeah. You're doing research. Okay, this number is way bigger than that number, right? Okay, but let's figure it out.
Oh, sorry.
That's okay. I get it.
That's what I got.
A lot of you did this, I think.
Yeah.
Yep.
Okay, I'm not going to go that route. I'm just going to go 1225. So this is for you, Dalen. The way you did that last problem. Just divide those two together. So 245 goes into 1225.
5 times exactly.
Okay.
Wait.
Right? 245 doesn't go into that, doesn't go into that, doesn't go into that. But it does. All right, so I'm going to check. 25, 22, 12. 5 times. Yay, I got 5.
It's 500.
Okay, so remember, we get 5 when I just divide. Twice. 1, 2. Okay, what this means, guys, is that the original amount went up 500%, went up 5 times to get to the new amount. So that's a big increase, isn't it? 500% increase. That's huge. Does that clarify your estimations, guys? You're kind of like, oh, oops, you flipped it around. That happens.
I got 500%.
Actually, speaking of estimation,
I don't like
Because
it.
we knew about
estimation helps you to make sure your answer is reasonable. So like if you're not estimating, you're just, I got 50, and that sounds great because it looks good, but it's wrong because it's way off an estimate. Yep.
So, like the last one when I asked about like moving the decimal thing, is that only a fifth decimal?
If you just divide these two together, you get 5,
But so.
and then you move it twice. If
I
you
did
use
the
a
proportion.
if you do, you don't have to move the decimal,
And
which is nice.
But I didn't have.
There's no decimal in there.
Yeah, it's,
So you don't have to move it.
you don't have to move a decimal. You just whatever you get, you keep it.
It has a decimal.
Yes.
Numbers have a decimal.
I decided to simplify it,
But you can.
somehow I messed it up somewhere, and I got 245 divided by 47.
Oh. Did you go 5 into both of these?
Yes.
So 5 goes in that. 4, 9, 49. Mm-hmm. Okay. All right, now we're going to look at percent of decrease, which, spoiler alert, we've already kind of looked at. Percent of increase, guess what? Your number goes from the original to the new, it goes up. Guess what happens on these problems?
It goes down.
Which,
Wait, does that mean you have to add them, or do you still have to?
so
subtract?
let's see how we
And then it
handle.
turns negative?
No. Okay, here we go. I had to first find out, all right, if the original was $38 and the new amount was $24, then what is the amount this time of decrease? That's all I'm looking for. Amount of decrease. So what do you do with those two numbers? You're trying to find a decrease.
Subtract.
Subtract. So it's 38 minus 24. $14. That's how much it went down. Does that make sense? It went down. That's the amount of decrease. That's the amount of decrease. Guess what the formula is? I'll get yours in just a moment.
Can I guess?
Yeah, go ahead.
Is it the original?
Amount of. Yeah, I think you were going to flip it.
Yeah, the decrease
Amount of decrease over.
over the original.
Yeah, it's the same thing. Hopefully it's not confusing, right? You get that amount of decrease or increase and put it over the original amount. Figure out the percent. Go ahead and do it on your own, guys. I want to see how you handle it. Yes.
So with the original amount and the new amount for both of them, do you always just do the bigger number minus?
Yeah, because you're not going to get a negative number. You won't say it went down negative 40% because that actually means it went up 40%. You're doing the opposite. Yeah, so just do the bigger minus the smaller no matter what.
Okay. Then I don't see how that's different then.
It's not different. That's the point.
Why is it called decrease then?
Because it's going down.
But it went down on the other one too.
So you went from original to new, it goes down, right? On the other two problems, the original to the new went up in value. So that's why they call it. And you have to be able to describe that. You're not going to say, well, yeah, this increased by whatever percent. You're like, what? It went down. So you say decreased. So you got to know which way it goes. Ma'am.
So is it still kind of the thing that we did last time, for where it's like, it was like, so if we do 14 times 100,
Okay, yes.
it'd be like
1,400.
1,400, or would it just be 14 because of what we did last time? Because last
Well,
time,
tell me what's 14 times 100. How about that?
1,400.
So 1,400. And 38 times x, 38x.
Okay.
Just
and
do it that
last
way.
time, last time when we did that times 100, it
Uh-huh.
made a change. You didn't like write it down as like a change.
Oh, okay. So I did it. So what I did on that problem
Oh, I did the
is all I did was 14 divided by 38. I wrote it as a proportion to help some, and then I just divided. Yeah. But both ways,
Round the answer, please.
yes, round it to the nearest. Let's see, there's some percent of decrease. A tenth of a percent. Tenth of a percent. So it should be blah, blah, point, blah, percent. That's what it should look like.
Blah blah point.
Okay, but I don't like doing this problem anyway because it's really mean. So why don't I reduce? Okay, so now I'm doing 7 times 100. 700. 19 times x is 19x. Divide both sides by 19. But Mr. A, why did you just change the 1438? It's because I divided it by 2 over 2. So I can do that. So 700 divided by 19. Okay, which is about 20, which helps me when dividing. 19 goes into 70. Awesome, 3 times. So that's 57, 13, 0, bring it down. 19, I'm going to go with 6, 54, 114. 6 times. Okay, so 114. That gives me 16 with an extra 0. 19 goes in 160. 6 times is 114. 8 times, so 72, 152. 0.8. Okay, but I have to go one more because I have to round to this place value. So 19 goes in 80 about 4 times.
Where did you get those numbers?
Hold on.
I just started doing
36.8%. 36.8%. Yes, ma'am.
I don't understand what I did wrong. I got 40%. And I just divided them and then I moved the decimal place because I got 0.4.
Yeah, I don't know. I got to look at it carefully and see if you divide it the right way. But it should be 36.8. All right, now listen to me, guys. You see this? See all this multiplication going on with the dividing? Don't erase your work when you're doing these. Please don't erase. Like you're like 19 times 6. That wasn't it, so you erase it. 19 times, that wasn't it. Because what happens later on? You might need it, and then you'll have it. It'll be there for you as a reference. Okay. So did this go up or down? This price go up or down?
down.
Down. So that's why we call it a decrease. Okay.
36.8% decrease.
Yes, 36.8% decrease. All right, go ahead and do this one. This is all you guys. Oh, it's time out time. This is not all you guys. It's a different problem. Okay, the last type of problem is look what they did for you. They gave you the amount of decrease, and they gave you the percent of decrease. So what else do they want? They want you to give me the original amount and the new amount. So you don't have any of that. Let's figure it out right now. To find the percent of decrease, you do the amount of change. And I'm gonna tell you what I mean by amount of change. Whoa. Didn't we say this was amount of increase or amount of decrease? You guys remember that?
Yeah.
Okay, it's in the notes. I'm gonna call it amount of change because it's changing up or down. It's the same thing. So we just call it the amount of change over the original amount. Over the original amount. We've been doing that every time. That is going to get me the percent of change. In this case, it's going to be decrease. So amount of decrease, original amount. Percent of decrease. Okay, you're like, that didn't help. Well, let's see what we can do. What's the amount of change?
$9.
$9. Do we have the original amount?
No.
No, I don't know. X. Do I have the percent of change?
20 over 100.
20 over 100. It gave it to me. So I had to find out X. And you can do many things to help yourself out. Boom.
Wow. I always forget.
And then, boom.
Slow down. Oh, goodness, Sammy. Demand.
40.
I'm lost.
I'll give you another one. Don't worry. X equals 45. Hold on. X equals 45. That's what part of that?
That's the original.
Original amount. Yes. And Jimbo, thank you.
Wait,
$45.
I didn't do that. I just did,
900 divided by 20.
wait.
You could do that. You should get the same thing. We should all get 45 no matter what you did.
I did 900. I thought
You
that
did
was
9 times
fun.
100?
No.
9 times.
Wait.
Wait, so don't we still
9 times 5 is 40.
45?
What?
Found a new.
Yeah. Don't we start?
Oh yeah, we're not done. So 45 is the original amount. How in the world am I going to find that new amount? It's like they gave me some part, but they didn't tell me if it went up or down. And how
45
to...
minus 9.
Oh, it's a decrease. What's 45 minus 9? Yes, 36.
So,
That's it.
Mr. A. So we we get that number,
The original.
no matter what, we have to do it minus the 9.
If it's a decrease, you minus. If it was an increase, guess what you would have done?
Plus
You would have added. The mystery is solved. All right. The ultimate tough problem here. I want an estimate of what the original amount is. Does anyone have an estimate? Raise your hand. Raise your hand. Give me an estimate. Yes.
I would say around.
So I want to know what the original amount is. What's that estimate? Don't say percent. It's not going to be good. It's not right. What do you think? 50, he says. All right. Yeah.
No,
Okay.
that's not it.
Yes, it's not.
No.
Caden.
105.
Okay, 105. Anyone else? It's not that.
Yeah.
Yep.
All right. 462.
No.
4,000.
Something around 4,500.
Something in the 4,000s range.
4,584.
Okay.
4,400.
Go ahead and get me the actual. I want the actual.
He's just using one.
The amount of change. The amount of change. Over the original amount, which we are trying to figure out first, is going to get me, and you could put it 12.5 over 100, or you could do 12.5 over 100, but 0.5 is probably easier. Maybe not.
How do people do it with fractions? I don't get it.
Yeah, you're going to have to do fractional.
Weird people.
486 times 100 is 48600, which equals 12.5x. Now, please listen carefully because a lot of you get right digits, but not the right place value. Thank you.
I was like, why did you stop?
I'm going to divide by 12.5. 12.5. All right, here we go. 48600 divided by 12.5. So
Yeah, but
48600 divided by. Now, if I move the decimal once here, I got to move it here, which, and I'm just going to put a little. All right. 125 goes into 486.
0 times.
I think I heard 3, which is.
Oh, I thought you said 48. Yeah, she knows what she meant.
375.
Oh my gosh, she's reading that song now. I can't sing it.
125 goes into 1,110. Okay, let's try. Which one you want to try? 8? All right. 40, 12. Oh, sorry, that's not it. That's 16. That's 20. 20. That's 1,000. All right, it is 1,000. It's 8 because that's 1,000. Then I get 1100 again. Wait, that's 8. Wait, that's 8. That's 8, 8, 8, 8. Okay, round it to the nearest dollar. So you don't have to give me cents, just round it to the nearest dollar. So it's 388 point. So what's the original amount? 3,889. That's the nearest dollar.
Wait,
That's the original amount.
wait. So you
Which is close to our 4,000 estimate,
Yeah.
give or take.
So you can't have a decimal?
No, you can. We could have said 0.89, but I just said round it. 8.89. If you wanted it. Okay,
Can I have 3888.9?
you could have, but just leave it like that. I'll say to the nearest dollar. And it'll say where to round it. All right, but what do I do? That's the original. How do I find that new?
Increase. Add the increase.
See, yeah. And when you said that out loud, I hope, what is that?
It is.
This makes no sense to me.
Good call. 4375.
Yes, almost.
4375. That's the new amount.
Correct.
Well, we wanted the estimate on the original,
Why
which
would
you
you
were.
add the increase and not subtract the increase? Because it's an increase.
Yeah, it's an increase.
Goes up.
Wait, I'm really confused.
Hold on. Hey, listen. I have 3 hands, and I had 2 people talking, and they didn't have their hands up. So let's go with the hands. Yep.
So, when you're doing these problems, which would be the answers on the homework, or will we give both?
Yeah, they're going to say what's the original and the new. So I want both. Okay. Yes, Henry.
The 3,888 was
Would be repeating?
It would not. Because you'd bring down the zero and you.
Oh, you get 1,000. You're right. Yeah, yeah. Right here. It just ends there,
No,
right?
we didn't.
Oh, no.
I did do it right.
Yes. Good job. That's good. That's a good call. I missed it. Yes.
How did you get 4,375?
Say that again.
How did you get 4,375? 74.
Oh, I did this number plus the increased amount.
Well, wouldn't it be 3,889?
Yeah, yeah. That changes if we did that, but I'm gonna go with this and then give you that. But you're right. It goes down by $1. Good job, Henry. Yep.
Did you know that if you stack every
Oh, hold on. That sounds like a great lunch question or lunch fact.
Mr. A. So I was in my work, and I was outline whatever I outlined like this, what it was doing, and I saw a face, so I made it.
Goodbye.